Let us look at comparison test 2. This test is also called the limit comparison test. Okay, now before we actually look at this test, let's see why is it required. Why is comparison test 1 itself not sufficient? So let us take the example of the series n by n square plus 1. Let's compare it with 1 by n series. So n by n square plus 1 is less than or equal to 1 by n, implies by cross multiplication, we get n square is less than or equal to n square plus 1. And this is always true. Now, let's look at greater than or equal to. So, n by n square plus 1 is greater than or equal to 1 by n, implies n square is greater than or equal to n square plus 1. And this is never true. And we know that the series 1 by n diverges. Since 1 by n diverges, comparing these two series really doesn't help us much. Why? Because we have a upper bound. N square is less than or equal to n square plus 1 is always true. So we have got the upper bound for this. But that upper bound is defined by 1 by n, which is divergent. So this only provides an upper bound which is useless when compared with a divergent series. So this doesn't help. Now let us compare it to a converging series. That is 1 by n square. So n by n square plus 1, is it less than or equal to 1 by n square? Cross multiplying, we get n cube is less than or equal to n square plus 1, which is not right. N cube is always greater than or equal to n square plus 1 for large n. So hence, no inequality suitable for comparison test 1 holds. So here, comparison test 1 is inconclusive. And because of this, we require comparison test 2. So let's see what exactly is it. So given two series, u sub n and v sub n, such that all the terms of u sub n are greater than or equal to 0 and all the terms of v sub n are greater than or equal to 0. But v sub n is greater than 0 for all sufficiently large n. Further, assuming that limit as n goes to infinity of u sub n by v sub n is equal to L in 0 to infinity. 0 and infinity are not included. So that means L is a finite value. So by the limit definition, choose epsilon such that L minus epsilon is greater than 0. Then there exists m in n such that the absolute value of u sub n by v sub n minus L is less than epsilon for all n greater than or equal to m, which implies u sub n by v sub n minus L is between minus epsilon and epsilon for all n greater than or equal to m, which in turn implies by taking, adding L throughout, we get L minus epsilon is less than u sub n by v sub n is less than L plus epsilon for all n greater than or equal to m. Now, multiplying throughout by v sub n, we get L minus epsilon times v sub n is less than u sub n, which is in turn less than v sub n times L plus epsilon for all n greater than or equal to m. Therefore, the series u sub n and v sub n converges or diverges together by comparison test 1. So here, in comparison test 1, we were comparing the series, two different series, term by term. Here we are comparing the limit. So let's look at an example. Let's take the series n plus 1 by n square. Let us compare it to the series 1 by n, which is divergent. So the nth term of both the series are u sub n is equal to n plus 1 by n square and v sub n is equal to 1 by n. Now let's take the ratio, limit of the ratio. So limit as n goes to infinity of u sub n by v sub n is equal to limit as n goes to infinity of n plus 1 by n square divided by 1 by n, which is equal to limit as n goes to infinity of n plus 1 by n, which is equal to 1. So here L is equal to 1, which is a finite value. Since the series 1 by n diverges and the limit of the ratio u sub n by v sub n exists and is a positive finite number, by comparison test 2, we can say that the given series also diverges. Let's look at another example. So now we have a series n by n cube plus 1. Now let us compare it to the series 1 by n square, which we know is convergent. So u sub n is equal to n by n cube plus 1 and v sub n is equal to 1 by n square. Now let's take the limit of the ratio. So limit as n goes to infinity of u sub n by v sub n is equal to limit as n goes to infinity of n by n cube plus 1 divided by 1 by n square, which is equal to limit as n goes to infinity of n cube by n cube plus 1, which is equal to 1. Again, the limit L is equal to 1, which is a finite number. Since the series 1 by n square converges and the limit of the ratio u sub n by v sub n exists and is a positive finite number, by comparison test 2, we can say that the given series also converges. So that was comparison test 2. If you found this session helpful, please do like, share and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.